In our previous tutorial, we looked at running an embedded Tomcat server in IntelliJ to connect to the MariaDB charity database. Here, we define JNDI in the running or embedded instance of Tomcat using Java code in the main method. In this tutorial, we will create a standard Java application, also known as a jar, that will launch an embedded Tomcat web server and set up and connect to MariaDB through Spring. We will read in the data source from the Spring application context.xml and also create a web.xml wherein we will define the Spring context load listener and the servlet that we use to get the catalog name from MariaDB. For my YouTube students, this slideshow is part of a YouTube playlist. The playlist URL will be listed in the description and comments of this lesson. All source code for this playlist will be available for free in a GitHub repository. These are the high-level steps we will perform in this lesson. First, we will create a new JDBC5 connection module in IntelliJ. This will, of course, be a Maven module. Next, in step 2, we add the Maven dependencies for the plugins and for Tomcat and Spring. Third, we define our data source in the Spring application context.xml file. In step 4, we define the web.xml, and inside the web.xml, we specify the Spring and Servlet entries. In step 5, create the main method to launch Tomcat 8. Here we can reuse a lot of our previous tutorials code. In step 6, we read in the MariaDB data source from our Spring application context.xml. And then finally, in step 7, we access the data source Spring Bean through our servlet code. Here we are back in IntelliJ. So first, let's have a look at our current Git branch. We are in the start branch of the embedded Tomcat with JDBC and Spring data source. So first we will create a new Java Maven module using IntelliJ, and we will name it JDBC5 Embedded Tomcat Spring Data Source. We won't be selecting an archetype. Looking at our artifact coordinates, that all looks good, and we select Finish. Here is our generated Maven module. You see there's no code. So we'll start by creating the package. We select the Java source directory, new package from .d for designs. And now we will update our POM file to bring in all the required Tomcat dependencies as well as the new Spring dependencies. I am cutting and pasting once again to save time, so we'll start with the properties. Next up, I'll bring in all the dependencies. And as we can see, there are new Spring dependencies. So bring in the Spring context and Spring JDBC, and then we reuse our old Tomcat dependencies that we used in our previous tutorial, as well as our MariaDB Java client. And we also bring in the new Bolt plugins. Looking at the Bolt plugins, we bring in the App Assembler Maven plugin that allows us to assemble our web application as a jar and run it from the main class. We also bring in the Execute Maven plugin, which allows us to execute our jar from the command line after we have packaged it. Update Maven, going back to our Markdown documentation. We've updated the package to be a jar. We added all the required Tomcat dependencies. We have added all the required Spring framework dependencies to get the Spring context. We added the Maven Bolt plugin that allows us to run and package it. And we've updated the parent POM and global dependency version numbers right up here. And now on to the next step, where we create a new web app, web.inf directory underneath main. Then we define the data source bean in the Spring application context.xml and in the web.xml. So first we create these files. We created the application context, and we'll also create the web.xml. And inside the application context.xml, we define our MariaDB data source as a Spring bean. Here we've defined the Spring bean inside the application context.xml. Now we have to update the web.xml. And immediately IntelliJ picks up the new defined web framework, so we configure it. The display name, let's call it the artifact name. We specify the context load listener for the Spring Web context, and we specify the context configuration location as the application context.xml file. We map the hello servlet to all the inclusive patterns after the backslash, and we specify our servlet class as hello servlet. And we see that IntelliJ picked up that we have not yet created it. So we use IntelliJ to generate the servlet for us. And then we can go back to our previous tutorial and bring over some of that code. We annotate the web servlet. Then we bring over the message string and output. We add the init method. And we see immediately IntelliJ picks up that we need to add the db-util. We're still not finished. We add the output print writer. And we add the empty destroy method. Now we can move on to the db-util, and we will reuse basically all of our code from our previous db-util. And now here, we are not going to look up the data source from JNDI. We are going to discover it through Spring. And this means we're going to change the create connection as follows. We're going to pass in the web application context that we get from Spring. And from this web application context, we are going to get the data source bean and return it. So we'll pass in the web application connection here as well. And as IntelliJ points out, we need to change our initialization method now to get the web application context. And this we will do as follows. We use the Spring Framework web application context utilities, and we find the application context, which we already set up here in the application context.xml, and we set up the listener, which means at this stage we are ready. And this time, instead of running it from within IntelliJ, we are going to cover running it from the Maven plugin. And this is the Execute Maven plugin. Now looking at both the App Assembler Maven plugin and the Execution Maven plugin, we see that the main class is defined. And inside the main class, of course, we run our main method. So we can reuse our previous main method, copy, paste. And since we are not using JNDI, but actually Spring, we can remove the logic for JNDI, deleting the whole method. And now we will start Tomcat on step number 8. And revisiting our web.xml, we see that we have specified the context load listener from Spring, and we have specified the context config location of the application context.xml. And in the application context, we have defined the DataSource MariaDB DataSource bean. So going back to our POM now, let's try and run this app using the Maven execution plugin. And we see it has not found the main method. Now, in the interest of saving time, I went back and had a look at the pom.xml to fix it. And unfortunately, this is what happens when you cut and paste. But we had a double com.com here. And looking at the web.xml, we had the lowercase web.inf defined here. So I had to go back and change web.inf to a capital web.inf. So let's try and run it again using the Maven execution plugin. Maven execute Java. And it is up and running. So going to our web browser. And that is it. We now know that it works and that we get our data source from Spring application context bean, and it gets read in through Spring context load listener. And this concludes this lesson. I will see you in the next tutorial.